Hello, let's continue our Sudoku adventure with Printing Diagonally by Strosahl. So we have normal 6x6 Sudoku rules, meaning in every row, column, and 2x3 box, we are placing the digits 1 to 6 exactly once each, except this is actually a Sudoku X, meaning in addition to all that, we also have these blue diagonal lines going down the main diagonals, and each of these also has the digits 1 to 6 exactly once each. They work just like a row, column, or box, but they're these diagonals. We also have these printing lines in the grid. So there are lines, there's an arrow at one end, and then there's a circle somewhere on the line that counts as part of the line. So whatever digits are on the line, let's give an example. Basically, whatever digit is in the circle counts how many times the digits along the line appear in the pointed cells. Another way to put that, kind of a backwards way to put that, is whatever digits are in the pointed cells, you count how many of those appear on the line, and then that count goes in the circle. So you count how many of these appear. So let's give the example now. So line 1, 5, 3, 2. Let's do. I don't think I have a good example line here to do that with. So let's actually just make up an example then. I want to use one that's diagonal. Let's use this one, I guess. So if I were to put 2, 3 here, then we want to look at these cells, these 4 cells, so I'll just highlight them, that are pointed at by this line. And 2 of them should match 2, 3. So I could actually use 2 twice if I want, 2, 2, and then 4, 4, 6, right? So if we were to count of 2, 3, we have two 2s and then nothing else, right? So that's 2 of them. 2 of them match these, right? So that's why the 2's in the circle. If this was instead 4, 3, then I need to do something like 3, 4, maybe 4, 3, like that, right? Because 4 of these digits match a digit on this line. The 3 matches, the 4 matches, the 4 matches, and the 3 matches. I know there was confusion the first time we used this constraint, so I'm trying to spend extra time explaining it. So let's do another example here. If I do 1, 3, 5, 6, I don't really care that much about being a proper example, but fine. I'll do 1, 2, 3, 5 here. What this is saying is that 3 of these digits would then match one of these, which I think is actually not possible. So let's switch that. So we would do, say, maybe 1, 2, and then like 4 here or something, right? And so the 1 and the 2 match these digits, the 6 and the 4 don't. So anyway, I'm running the risk of accidentally starting the solve early. There is a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. Okay, so I do think this is a good place to start because I think this has to be 2. I think we have no choice. Like, first of all, these 2 digits, or I guess the first thing to say is these can't repeat at all. These are going to be 4 unique digits. These 2 digits are not going to appear in these 4 because these 2 digits are different. So they can't appear down here. It's all in the same column. Now, these 2 digits must appear down here because this column needs every digit. And so these 2 digits aren't here, so they're down here. So that means exactly 2 of these digits will match, including the 2. And I honestly think that this is all we need to do. Like, Sudoku will take care of the rest other than filling this 2. Okay. This one is pointing along here. So these 2 digits are going to appear somewhere up here. It's the same deal, right? We have all 6 digits along this diagonal. This one's not going to appear again on the diagonal, so this one we don't have to worry about. And these 2 digits are different than this one, and thus must appear somewhere on this diagonal. So this is another 2, and the rest should be taken care of by Sudoku in the diagonal. Here, we're only pointing at 2 digits, so this is 1 or 2, but it can't be a 2, so it has to be a 1. And so that means that we are going to be needing... Oh yeah, and so we're going to need either this digit or this digit to appear on this line. But this digit cannot appear on this line because it shares a row or a box with all of the digits on the line. So we actually have to put a 6 on this line so that it matches that 6. These 2 6s look up, putting a 6 here. Okay. This we don't know much about. I'm not sure we can do anything with that yet. Is there Sudoku I can do? I mean, there's a 2 in one of these two. 1, 2. Does that have to do with this diagonal? Okay, so this only looks at 3 digits. So this is from 1, 2, or 3, but it can't be a 2. So it's from 1, 3. So that means we need 1. Well, if this was a 3, then these would all be from 3, 6. Is that possible? I think that is possible, for sure. In fact, we do have a 6 in one of these two. Oh, right. Okay, so this 6 looking here puts a 6 in one of these two, but this 6 sees down the diagonal, so that is a 6. Can we do more with 6s? There's a 6 up here. There's a 6 up here, and that's it for 6s. So this diagonal is going to need a 6. It can't come from here, it can't come from here, and it can't come from here or here. So this is the 6 for that diagonal, and that's a 6 as well. Okay, so all the 6s are done. So that means, okay, we are seeing 2 6s already. So this has to be a 3, and this can't be another 6, so this is a 3. Okay, that is actually what ended up happening. So 3 in one of these two. I'm worried about the 3 in this diagonal now. So this 3 sees here and here. This 3 sees here. These pointing 3s tell us it's not here. So there is only one place for 3 in this diagonal, which is there. Maybe we do doot in the corner. These two 3s look up. 3 looks in, there's a 3 there. And this 3 looks in here, this 3 looks down, putting a 3 over here. Oops, 3 over here. I don't think we have to worry about this cell. We still don't know anything about these cells. Well, it is 4 cells, so we can at least put 1, 2, 3, 4 here. It can't be 2 or 3, so it's 1 or 4, which is more reasonable. So if this was a 4, then we'd have to have a 4 here and a 4 here, and then whatever this was would have to pair up with it. That seems completely reasonable, to be honest. There's no reason to think it can't happen. There's a 2 in one of these. Maybe we just need to look at the diagonals more. What do we actually know about? What about 1s on the diagonals? 1 on this diagonal is a little restricted. It can't be in these 2 cells because of this one, but it could be here or here as far as I can tell. We might as well fill this triple. This is 1, 4, 5. What can I do here? How about this diagonal? We need a 3 on it. Yeah, 3 on this diagonal can only go here. These are the only 3s left to place. So that's a 3 and that's a 3. Oops, I didn't mean to do that. This column needs a 2. It can only go here. That puts a 2 in one of these two. This is a pair. We need 4, 5. So this is a pair. We need 1, 2. I need a 1. This is 1, 4, 5. I need a 1 down here. This whole box is 1, 4, 5. That's not a 1. 4, 5 pair, 1, 4, 5. 1, 2, 4, 5. This whole box is 1, 2, 4, 5. So these are 1, 4, 5 as well. What's resolving this? Is it this? So I was saying that if this is a 4, then we need the 4 to match up with another digit. Pair up here and pair up here. I am seeing something, though, that's not related to this, which is we need a 2 on this diagonal. It can't go here, so the 2 ends up here. That gives us the 1 and the 2 here. Okay. So if this was a 4... Let's see, this isn't 1. This is 4, 5. Let's actually do some more Sudoku here. These are... Yeah, I need a 2 in here. 2 is placed. This is 4, 5. This is 1, 4, 5. Okay, and then these are also 1, 4, 5. All right, that's not a 1. So what I was saying is, yeah, there is a 1 on this line. That's what I was about to prove, is there's one on this line, but Sudoku just did that for me. It's going to prove it by saying, well, either this is a 1 or it's a 4, which then forces this to be a 1 so that this can be counted. I guess the question is, can this be a 1? That would mean that this would be... No, we can't. Oh, that's really interesting. So if this was a 1, imagine this was a 1, then whatever this 4, 5 ends up being is not allowed to appear at all in here. So these 4, 5s would be the other 4, 5. That seems okay. But then we'd have to make this cell not a 1 and not the same 4, 5 as this one. But these, so I guess here's an easier way to prove it, right? A little bit more straightforward. If this was a 1, right? If this was a 1, we can't have 2 1s along this diagonal. And so that means that this ends up not the 1. This ends up a 4 or 5 pair, which means that one of these 4 5s will match this 4 5, and it should have been a 2. So this actually does have to be 4, which makes that 5 and that 1 and that 5 4. I might just finish the puzzle. That's 4. These aren't 4s. These aren't 4s. These aren't 4s. Okay, it doesn't quite finish. We get 5 and 4 and 4. Now the way to finish it is all 4 of these need to match either 1 or 4, so this cannot be a 5. So that's 1, that's 5. That's 1, that's 5, 5 and 1, and there we go. So this arrow did an amazing job of just finishing the puzzle. It had a ton of options without this arrow. That's really neat. Cool. Well, nice use of the constraint Strosahl. We had to use everything. We had to use Sudoku, we had to use the X, we had to use the printing lines, and it kept jumping between them, which was really neat. So always thinking about, okay, which thing am I supposed to be doing right now, which is always good. So cool. I hope you enjoyed it as well. If you did, then why don't leave a like, subscribe, and a kind comment below.